Excellent. There we go. Thank you for joining this live stream. Today I got a whole bunch of stuff to tear down, and we're gonna get right into it. I've got some stuff that I want to reassemble because I'm gonna do some experiments with some motor controllers. And then I've got a bunch of items that I pulled out of the trash today, and they're gonna get tore down too. So let's do it. You guys might remember this guy. This would be my pump, my air pump, and I never put him back together, which is a shame because now I have a 3-phase motor controller. This is an ESC. It's 120 amp. Hopefully I can power it off of something like a 36 volt, maybe 48 volt. We'll see. I'll see what I have to do. Maybe I have to beef up the cooling solution. But this is going to power this guy. And it's going to be a real fun demonstration of 3-phase power because this ESC takes in regular DC, as you can see here, and it kicks it out into 3 different phases. Now they use these guys here for brushless motors. You can see here I've got a 3-phase brushless motor, and it will connect up to this guy like so, and it should power it. Now they use these guys for RC cars and stuff like that, but I'm not going to use that guy right now. I am hoping to power this guy, since I haven't been able to find any stats on what voltage this guy is supposed to be. I'm hoping to kick out maybe 48 volts on 3-phase, which when I keep talking about 3-phase, you can see right here, your 3 wires. So that should be a brushless DC motor. But not in this video. In a future one, I'm going to power this guy with this, and we're going to do some pulse width modulation experiments. It's going to be really cool. You can find these guys here on Amazon, quite cheap. Like I said, they're for hobbyists and for radio control cars and stuff. But I'm going to program it and use it as a speed controller for this guy here. Now normally, I think I would be better off using a VFD or variable frequency drive. And I don't know, maybe I'm going to switch over to a VFD. I've got one over here in my CNC machine, and maybe I'll get another one just to experiment and drive it. Sneed, you got a job as a biomed tech? Field service, that's excellent. 18 an hour? That is a reasonable starting wage. Now remember, you get comfortable with your job and you work really hard, and then you use that to push forward. Push forward. Never, even now, I'm paid quite well at the job I'm at, and I never technically quit looking for a job. And that's the truth. Even if it's in the current place that I work at, you know, if there's a job opening that's coming up, maybe a biomed manager or supervisor or something, you betcha I'm going to apply for that job. Just because, keep pushing forward, keep moving up, man. Good for you, Sneed. It's quite all right. You know, you want to know the truth? I don't have a degree either, man. I don't have a degree. And yet I run a team in one of the biggest hospitals around. So that's perfectly fine, man. Just use this as an opportunity to learn, okay? Use it as an opportunity, man. Excellent. That's really good to hear. Where'd you get a job? What city are you in? Mr. Sneed does not want to rate me back. All right, Sneed, I'm going to push forward, man. I'm going to continue putting this guy back together because I really do want to power this bad boy with this ESC controller. And if I catch it on fire, then I catch it on fire. I don't even care. So all the various parts to this bad boy. Let's see, what orientation do I want to put it at? Probably off to the side. That looks beautiful. Now, normally when you have a rotating mass and you have fasteners, you want to put some Loctite on them, okay? Because you don't want that coming apart, and which, I mean, if you can see, I've got a counterweight right here that rotates inside this bell housing. If these screws come loose, they will destroy this entire thing. So I'm going to go ahead and put Loctite on it. Look at this. All right. You guys have never seen this Loctite before. This is made by Permatex. It's some pretty cool stuff. It comes in a bottle. You just twist it and a little bit comes out the end. Makes for a pretty neat application. It's like a paste, so it stays on the threads a little bit better than some of the stuff that you might be used to, like the squirt bottle. I don't know about you guys, but with that stupid squirt bottle, every time I try and close the valve on it, it wants to squirt Loctite across my work surface. It happens every time. It happened today. So all right. The head on this guy is tapered. You can see that? And use the taper to spread across the threads. What a neat applicator. I dig this. I use these guys here to Loctite every single fastener on my CNC machine. And if you guys can imagine, there are a lot of fasteners on that guy. Hundreds. They're all over the place. There we go. Okay, so you guys notice I'm putting this back together. I'm putting them diagonal. That way there it lines up the piece as best as possible, and they're not being tightened down. You can see that these are taper head screws, and actually you can't see it. Jeez, there you go. See that? They're not tightened down. Okay, make that mistake. You get into some of these precision machine parts, and you go to get the last fastener in, and it won't go in the hole because you tighten down one of your fasteners. I think we've all made that mistake. All right, now that they're all in, I'll tighten them down. Again, cross pattern diagonally. I don't know about you guys, but how many of you guys have Loctite in your toolkit? I'm telling you, man, there are so many people that do not use Loctite as biomeds. They'll get a call that something's coming loose. They'll show up on site. They'll just tighten it down a little bit with a screwdriver and then close the work order out. When you know it, you're going to be back there in a month, maybe a week, maybe a day, who's to say, doing it all over again because you did a half-assed job. True story. Happens all the time, man. Okay. So it looks like, okay, it looks like this counterweight right here, it looks like it wants to go all the way down. So I'm going to have to space it a little bit. Ooh. I wonder, I should have measured that before I pulled it apart. Well, I'll come really close. So you can see right here, the other end of the counterweight, it fits into a pilot bearing right here. And you got to have that just right, because if you have it too short, you're riding, you know, uneven in the bearing. If you have it too long, it won't clamshell together correctly. Ah, goodness. I should have measured that. okay, I really want to get this guy back together because it's sitting here cluttering up my bench. And guys, I have been cleaning my shop here because I've come to this kind of realization that I'm probably going to end up selling almost all my power tools here. So if you can see my whole entire CNC right here, I've got a large bandsaw, my table saw, which is over there. I've got a belt sander right here. I have a cast iron router table that's right on the other side of that. I've just got a lot of stuff in here, and I just don't have enough time to use it. Between this, what I'm doing right now with YouTube, and between my job and my family, it is just absolutely crazy trying to get some of this stuff done. So I guess I'm gonna sell some of my stuff, man. That's okay. Maybe I'll invest some of that money. Wow. That's going in really tough, man. I might have to heat this up later and continue this guy later because I want to get into some of these teardowns. I was hoping that this would go together a wee bit smoother, but this is it's almost bending my Allen wrench. It's so tight. That's crazy. Wow. And it doesn't appear to be tightening down too much more. Oh, shoot. All right, well, I'm gonna have to deal with that later. That sucks. Oh well. Tools are consumables. It is what it is. But my overall goal is to go ahead and pull this guy, put this guy completely back together, and make a scroll compressor with it. That'd be very cool. Because these guys, what they do is after a certain number of hours, it becomes a consumable part that's changed out as part of a PM. And because of that, it's a perfectly good pump. It's just, you know, for life support, it's not recommended, but well. So, yep, that's to be continued some other time. Anyway, if you guys have never tried this Permatex Loctite, I've got red, I've got blue. This stuff is really nice. And it's obviously pretty neat. You can throw this in a toolbox. It doesn't leak all over the place like the bottles do. I think everybody has had the bottles leak all over your toolbox. Let's put some of this over here. And let's tear down some stuff, man. How much experience do you think a biomed needs to land an in-house job? I know biomeds that have little to no experience and they land in-house jobs. It depends on where you are working. Some places the market is extremely competitive, and some places it's not. So, hard to say. And I would agree with Jay, a solid year with good work ethic and showing that you're completely capable will definitely get you an in-house job. I completely agree with everything he says there. It's all about your personal motivation, man. Oh, look at this. Oh, look at this. It's still got battery power. Oh, this poor guy. He doesn't even know what's going to happen to him here. Matthew says, should I go to GE school for radiant warmers and incubators? You know something? I don't know. Do you want to do radiant warmers and incubators? Do you want to get stuck with pediatrics? Don't think that when I say get stuck, it's derogatory. It's not. If you like doing pediatrics, you like doing, you know, labor and delivery type of stuff, then sure, you go for it, man. Get all the training that they're willing to pay for. Just get it, because some places do not want to pay for training. I could elaborate on that, but at this moment I don't want to. Just one of those things. I've been at hospitals that do lots and lots of training, and I've been at hospitals that almost never train their technicians. It's the craziest thing. Life Delights, welcome, man. How are you doing? The 420 series. I thought you were talking about something else there for a moment, but yes, you were right. This is the 420 series. You know what's crazy is these guys here, if they are not currently end of life, they're almost at end of life. And that is so crazy, because I can remember when they rolled these out as the latest and greatest. And as a biomed, that's the weirdest thing, when you see technology go full cycle during your career and it's no longer like in play. They're trying to get them off the streets. That's so wild. You know something? I see something else going on right here. Let's take a look. Let's take a look. See what's going on. There we go. So this is a lead acid cell. Yes. All right. There's always some surprises. So in another video of mine, I was telling you guys how batteries and battery packs often have onboard fusing. You can see right there. It's as simple as it needs to be. They just soldered wires to a blade fuse, and there it is. So it's possible, if you have a battery error on a device, or you think it's a bad battery, it's entirely possible with some of these lead acids that all you got to do is solder a new fuse on and keep going. But remember, fuses always break for a reason, right? It's not just because you powered it up one day and it magically popped. I am dealing with this right now on a device. We all fall to that process where we think, I'll just change out the fuse and we'll see what's going to happen. Well, I'll tell you what's going to happen. You're going to change out that stupid fuse and it's going to pop again, because they pop for a reason. But this is an R&D battery, so R&D soldered that guy in there. Wow, and that's some crazy tape that they put. I'll stick him off to the side. Oh, let's see, what do we got? Lots and lots of holes. I love these WEHA precision screwdrivers. You guys see that I use them all the time here on my benchtop. These things are wonderful, because not only are they a precision screwdriver, so you can, you know, get them into really tight spaces, but they're really strong. I've never ever broke one of these, and I have horsed them quite a bit. You've seen in some of these videos, I just horse the hell out of them, and they don't break. Matter of fact, they don't even strip. I've got some Allens and some Torques. You would think that they would go the wayside, like this guy right here. That's what just happened on that Torques. It's twisted. That hasn't happened with the WEHA. They're German brand tools, German manufactured, but they're not crazy expensive. I would say a tool set like this would probably cost 2 or 3 times the amount if it was if this was going to be snap-on or something like that. Oh, let's see what we got. There we go. All right, so it looks like this is a 2 millimeter. Let's do it. Get it. Where'd you go? I'll find him later. Here I thought I was using my cool little blue mat here to capture all the fasteners, and I lose one. That's just how it is. Wow, these things have a bunch of fasteners in the back. You would think that these guys who want to simplify their manufacturing processes. But you can tell that this is an accessory. It's an add-on pack because they got all different thermometers. Welsh Allyn loves doing that, having a bunch of options for thermometers. Maybe options aren't always a good thing, you know? Patrick, what's up, man? How you doing? Oh, yes. Here we go. All right. You can see right here, we got some of those membrane buttons. They actually sell a kit. If you ever have this this conductor that's on the back of these pads, if you ever have it wear off due to cleaning solvents or something, there is a kit. I've seen it once before at Fry's Electronics a long time ago, and I was going to buy it, but I just on Amazon. It's a kit to restore the backs of these buttons so that they're conductive again. So if you can see right here, you can see the grid. Oh, hold on. Focus. Focus. It just looks like it's copper pad if it's not focused. Come on, man. Oh, this camera. Guys, I know I keep saying it, that I'm going to change out this camera. This camera is not my favorite. So there is a grid right here. You know, part of the lines come from this side, part of the lines come from this side. And what happens is those buttons come down and they short against one side to the other, and it, you know, registers as a button press. So often what you'll get is corrosion here on these, and also it often eats away at the backs of these buttons. But what I really like is these buttons are not flush to the front. See how they're kind of proud to the back? You can see that. Well, that means that the solvents aren't going to go down and seep in around your buttons like they have done on so many other devices. It's actually a pretty good design. So I got some rubber standoffs here for the display board. Let's see, I've never pulled one of these apart, so this should be really interesting. If I break it, I break it, right? This one came out of the trash today. All right, there you go. Okay. Let's see, I'll pull it off the motherboard. All right. So this is a pretty neat way of putting stuff together. There's rubber grommets that hold it in suspension above the rest of the platform. That is a cool design. You see, I just pulled it straight up. No extra fasteners for assembly and manufacturing. That's going to be wonderful. You got two of the blob gobs right there, which are your controllers for your buttons. And that's it. Kind of a simple display. Somebody cracks that, I imagine it's real cheap and easy to change that part out. Oh boy, what do we have here? All right, I'm going to disconnect this guy. I don't really completely know what this guy is yet, so I'm going to hold off. Okay, I see 4 fasteners on the main control board. All right. There's a ribbon cable right here that it's probably really easy to destroy. All right, what do we got? So I have a pressure sensor right here. You can see that it goes through the PCB to the other side. It's a goofy way of doing it, but I guess it works. Okay. Here, tell you what, let's bring this guy down a little bit. Come on. This is time to bring it down. There we go. All right. So you can see my pressure sensor right here. Comes through to the other side of the board. Right here at the very bottom of the board, I have a connector which goes over to my pneumatic solenoid, which is going to be the relief valve for when it's taking non-invasive blood pressure. This is the tiny little pump that pressurizes it, and then it releases it. So you can see right here, it's got it's a filter, but it's probably acting like a muffler. So that's where it sucks the air in, and then it fills up your non-invasive blood pressure cuff with this guy right here. And when it is done with the blood pressure, or when you tell it to cancel and release, it activates the solenoid, and there's a little weep hole right here where it dumps the air pressure. Pretty simple. All right. On the control board, I have the alarm. Looks like 2 expansion risers right here. I don't know what those are for. And then on the back, let's see, what did that guy go to? Oh, okay. So that is your power input. I should have known based on the power controlling that's around it. I should have known. Oh, let's see, what do we got going on there? The Zener diode. I have a LM2941S. There's a few markings on the board, but not too many. And on the other side, all the components are labeled. They just don't really say what they do. Some boards, they clearly tell you, like, you know, test points and what to check. You can tell that Welsh Allen, this is just a depot level repair. You just change out that board, you're good to go. Okay, so here's that non-invasive blood pressure pump. It's just suspended by a zip tie. You know, I guess whatever works, man. But yeah, that's kind of simple. I see this dark piece right here, and normally that infers infrared, like infrared communications. Oh, look at that. Haha. Bingo. See right here? I have a transmitter and a receiver right here on the infrared. So those little 2 blobs. So this thing has some sort of infrared capabilities. I've never used that, but whenever you see one of these opaque, really dark colored windows, that's usually an infrared window, which is right there. I had no idea that these had infrared. You learn something every day, huh? All right. And over here, this ribbon cable connects to my temperature module. Like I said earlier, these things are an option. You can buy it with several different types of temperatures, temperature probes. So your temperature probe normally sits down in the well. When you pull it out, there is usually either an optical interrupter or a physical micro switch that detects when you pull the temperature probe out. And that's what tells it to go into a temperature read cycle. And you can see this right here is the port for connecting your temperature probe. A lot of these have replaceable wells. You can pull it out and put a new one in. But this one here, it's clearly screwed in. So you get what you get. Interesting. So that, my guys, is the Welsh Allen. What series is this? Is this the 420 series? Spot vital signs. This guy here was the standard for so long. This was everywhere. And now I find them in the trash. How crazy is that? Good. I'm going to put all this over here because I have other items to pull apart. What is next? Oh my gosh, you guys. I'm sure you guys have seen many of these guys. Here it is on my desk. I haven't been able to touch one of these in years because many large facilities do not touch these. They're either contracted out or we have a special team that's all they do is infusion pumps. So it has been years and years since I have touched one of these. I would say 6 or 7 years. But here we are. So these, this is part of the Laris CareFusion, whatever you want to call it, system. It's been rebranded, bought and sold so many times. This is actually just the pump. This is not the brains. There's actually a computer that this latches onto. And they had a really innovative latch system. So it just kind of rocks and slaps on. So you can see here is the male side. You can see the shape of it. And this right here is the female side of the port. And the problem is you will bend these pins, but more so, especially back when a lot of people were using the hydrogen peroxide wipes, these pins right here, if I remember it, it's some of the last pins down there, those would get so corroded, and it happened all the time, guys. It was so prominent, and these would melt. They would catch on fire because liquid gets down in there, and it just causes havoc. But let's see, where is it? All right. I have to dish through some of my parts. So this, guys, is where it really pays to have brass brushes, okay? So I keep stainless brushes. This is when you have rust and heavy corrosion and you want to remove material and get it off of there. Use brass. Excuse me, I can't even talk tonight. Use brass. I quit. Use brass brushes when you need to get in on contacts and clean them up. All right. So there's often corrosion on these. You can either use brass brushes like this or brushes like this. This one is really aggressive though. Just a little tiny brush like this. And all you got to do the brass is soft enough that it doesn't destroy the plastic, because once you erode the plastic between the terminals, it will short and it'll create a whole bunch of problems. You'll get corrosion here on the grounding strips on the side. You can clean those up, and the shop will let you use a little bit of vinegar, and vinegar will clean corrosion off terminals very nicely. Okay, so I have a whole box. You can see this box full of stuff I got right here. These were all part of my toolkit back when I was working in the operating rooms. Like I said, I got nylon brushes, I have brass, and I have stainless steel. And each one has a purpose. You can't just take a stainless steel brush and scrub your terminals. You will destroy the plastic in between them, and you will cut away at the terminals itself, because brass is way softer than stainless steel. Whereas brass, you have a lot more leniency when it comes to cleaning those terminals. Brass brushes, guys, I highly suggest y'all get some. There's so many biomeds that don't have brushes. It's the craziest thing. Just like biomeds that don't have Loctite. It's like, what do you guys do for a living? All right, guys. So that's the terminals. I've seen these catch fire. I've seen them corrode. It's really bad. It's a really good system, though. I really like these. It's just, you know, because of wipes and because of people just being a little overzealous, it just destroys these things. And as you can see, they're not hard to change out. You can buy these as spare parts. See that? Two fasteners. Comes right off. There's a terminal back there that it just uses spring-loaded pins to connect to. Very nice and easy. Right. Come on. Sometimes these guys are a little stuck in there, right? Because of goo juice or something like that. So that is why I get a very nice miniature flat blade screwdriver and get you some help. You can see what I'm doing is I'm actually rocking it a little bit on the corners, and that will lift it right up, just like so. There we go. Give it some love down at the other side. All right. You guys can see what was giving me such a hard time. It has got this silicone gasket on the back side of it. If you see that these right here are deformed, if they're crushed or whatever, you might be able to straighten them back out, but highly suggest not, because if it doesn't have enough spring pressure, it will also melt your male terminals, because if there's not a good enough connection, and these things pull some amps. I'll tell you, when you are running a set through this guy, it pulls some amps for sure. So make sure you got good terminals. You should have those. If you're repairing these pumps in-house, you need to have those as a spare part on stock. The same with this guy. All right. Now this is one component that maybe the world of 3D printing might be able to change. I don't know. Are these large pumps on their way out soon? I wouldn't think so, because they're such a standard still. But look at the spring-loaded catch. This pawl is what creates so many hassles for this pump. It's the Achilles heel of this entire pump. They crack right up here. They snap off. As you can tell, it's a big dingle hopper hanging right off right there. They snap. It breaks this internal piece right here. You see that little white piece that keeps it from going forward anymore? It breaks that. So if this guy isn't calibrated correctly, then it will not interact with some sensors in here. We'll go into that later. But these guys right here, oh, they changed the design. Fusion, you crazy guys, good on you. Okay, so you see this little white nub right here on the pawl? It's right there. There used to be an actual set screw that went through the pawl, and you could adjust it. So if wear and tear made this guy not sit in the correct position, then you could adjust that little screw a little bit. But you can tell that they molded it. So this is a different revision from the last time I used to work on these pumps. Already I'm seeing stuff that's different. This is awesome. Hold on, guys. I'm going to go through some of these comments here, because I am not keeping track. I'm so sorry, guys. Sneed fixes veterinary equipment. That's very cool. I used to also do veterinary equipment when I was in the military. They will have you do anything and everything. Matthew says, ever work on vein viewers? Interesting that you said that. I have one that somebody wants me to check out. Vein viewers, I'm going to do a whole video on those. It's such a cool technology, but at the same time, it's so expensive. It is what it is. You want something cool like that? From what I can figure, the vein viewers, it uses a special orientation of laser beams, and it uses a special frequency. So I think what it does is it shoots out infrared, and it can detect where your veins are, because certain things will absorb certain light, you know, like, I don't know, veins, because of their coloration. I might be completely off, but I think that's what it has to do with absorption of light. And what it does, it leaves a blank spot where your vein is, so you can clearly see where it's at. You can even move it around in real time while this vein viewer is going on. I'm gonna do a whole video on it, guys, soon enough. AK says, do you ever deal with Cadwell equipment? What is Cadwell equipment? Please tell me. I don't know. Flocky says, great channel. It helps to see the actual work being done to fill in the gap, especially in the COVID area, online education. Flocky, thank you, man. I appreciate that. I've been doing this for about 2.5 years now. And, you know, I just recently got into live stream because I like interacting with people. Sometimes they have some crazy questions that I can answer live right here. Or maybe I'm saying or doing something wrong. Mind you, this is live. If I do something wrong, say something wrong here, It is what it is, man. It just happens. Oh my gosh. So anyway, that's the pawl on this pump, and that is the Achilles heel. You can tell right there. So this pawl has to come down, and it latches in, and it interfaces with some sensors inside. We're going to go over that later. And if anything is wrong with this guy whatsoever, your pump will error, will beep at you, and it will not proceed. So this is technically a peristaltic pump, not a peristaltic pump. It's a peristaltic pump. Okay, and there's a lot of stuff going on here. So let's see if we can go through it. We have some pressure sensors here and here. We can test those. We can calibrate those with the software that you connect when you do your PMs. You have here a plunger, and you have another plunger, and then there's two gates right here. And these two gates act like pinch valves. You know, they pinch it, so and then squeeze, and then pinch, and then squeeze. And what it does is it checks your incoming pressure, and it checks your outgoing pressure. So if there's an occlusion on the patient side, it knows. And if there is a bag out or something like that on this side, it will also know if your fluid's out. This guy down here has got a bunch of sensors in there. It's got several sensors. We're going to go into that. There is a hose that lays across here. This is a silicone piece of the hose that lays across these sensors. And then there's a plastic piece that notches right here. So it just kind of lays in there nice and neat. You have a door here with two springable bobbers on it. All right, if those are gone, this pump will not work correctly. So what that does is that creates spring pressure as this thing is squishing and squashing. So this adds and aids these peristaltic fingers, okay? So that's all it is it's squeezing a hose from one side, then the other side, then the other, okay? And that's all it's doing. All right, it's got your two gates right here. It's really not that complex, but you know, once we get into the sensors and stuff, that's when you're going to see some of the complexity. All right, let's see. Well, I might as well talk about the latching mechanism too, because the other Achilles heel for these guys, even though I thought it was a really good design, is this slide latch release. You see that? So you hit this guy right here. It releases the interlock with the neighboring pump. And when it releases it, that you can rock it out and pull it off, you know? So it's that simple. So you slide it on. When you go to release it, you press the button, pull it up, pull it out. So it's a really cool design. But there's goo juice that gets down in there all the time. Notice I'm wearing gloves. I'm not doing that because I'm paranoid. We wear gloves because you never know what's going to be inside this guy, okay? So the other thing I want to point out, you see how bottom of my latch is nice, all right? What happens is, for whatever reason, these latches get cut off, they get broke, there'll be sharp edges. If this is sharp whatsoever, you got to change out this whole latch assembly, which is you pull this one screw out here, the whole arm comes out, you put the whole new arm in with your spring. I got really good at doing this. So there's a flat blade right there. You know, why not? It's not like I'm going to run this pump or anything, right? I have not taken one of these apart in so long. Come on. Wow. Guys, that guy does not want to come out. It does not want to come out. Okay. It's going to get its wish. Let's pull apart the other side so I can show you some of the hinge pins. There has been several issues with these over the years. This is obviously a much newer revision than what I'm used to. Underneath this guy right here is the hinge pin, which always snaps off, or at least it used to, back when this was an Alaris pump. And I would like to think that they updated that as well. Okay, let's pull the cover off. This guy. Oh, wow. Okay. All right. So there was a kit going around for a while where you could actually go through. Here, let me just undo this guy and this guy. Come on. And this guy. So there was a kit for a while where you could actually replace this nub right here. There was a drill bit that was included along with an insert. So you drill it out, and there's a jig that you kind of line up, you drill it out, and then you put in a new pin, and then you put your door back on and you keep trucking. This pump has obviously not been abused too much. This is one of the nicer examples that I pulled apart. So this right here, this is going to be your front door controller. And I want to pull this off because it's got some really cool features. Oh, let's see. Don't laugh at me, guys. Like I said, it's been a long time since I pulled one of these guys apart. All right. So that right there looks like it's just a ground. Okay, whatever. All right. So here's some of the cool features of this guy. Let me pull this guy up nice and careful. Come on. There we go. Okay. And the membrane buttons. So underneath this label here, there's membrane buttons. You see that? And those come through this little ribbon cable, and they connect to this board. So this board right here is your controller for the front end. I don't know if this board here is what talks between the modules. I'm pretty sure that is in here. We'll get to that in a moment. But this guy here does control your readout. I don't know if these are little miniature OLEDs, but you have your 8-segment display. You have your pump channel number. So if you have 2 or 3 of these connected in sequence, you'll have pump 1 or pump A, B, C, or something like that. So that's going to read out on this little guy right here. This is going to be your infusion rate, and you're going to have alarms plus whatever it is that you're infusing, whatever the drug is. That's going to read out on this guy right here. So this guy right here, you've seen that I disconnected this fiber bundle. That is, I always thought that was a little over-engineered. So this is a fiber bundle that comes here to the front panel. I don't know why they did it that way. It seems like such a, an overdone process, because nowadays, we have miniature LEDs that can do that perfectly fine. And this guy up here is your alarm light. You can see here at the top of the door, this whole opaque white, actually that's translucent. So this guy here will change color based on the alarm condition of the pump. So if it's green or if it's orange or red, something like that. So this guy here will illuminate, and that is done with this guy right here. And if I remember correctly, this little tiny LED at the top is a 3-color tricolor LED. I might be wrong. It's been a long time since I've actually seen one of these guys up and running. So that is the door. This guy is extremely complex. A lot of complexity revolves around this guy right here. And I'll show you that in just a moment, because it interfaces with this. So on the back of this pump, there's 2 large fasteners. We pull these apart, and the whole front end should slide right out. Oh, just like that. So sometimes they got a little complex with their manufacturing, and then other times they did it perfectly. Alaris. So you can see, I talked in other videos about the coatings that they spray on the inside of these plastics. You can see it here, this silvery coating on the inside that acts like a Faraday cage. If I remember right, that is all conductive, and that is just a cheaper way of doing it than building a metal cage and encapsulating this. Oh boy, where did we start? I'm just going to start pulling some pulling some boards off. All right. You can see this ribbon cable that connects the two modules. So all you gotta do is get a small flat blade screwdriver and just kind of get it under the edge and rock it. They pull right up, no problem there. And then you can get your fingers under this. Now, mind you, a lot of people pull these up at an angle. I've gotten used to pulling on ribbon cables. Put your finger under it and keep your finger stiff so you pull the ribbon cable out evenly, because if you pull this connector out at an angle, you'll bend some pins and you'll booger it up, right? So just like that, pull it straight up. Okay, what else we got? So here's my little motor assembly. And some power wires. All right, so these are the communication wires to the front door. There we go. Ground strap. Let's see. One screw right here. And this miniature guy. Let's see if I can show you guys. There's a little black stud right here. And you have to pull up the center point, just like that. Just like that. Then you can shove your miniature flat blade screwdriver down at the base. Make sure you don't scar up that PCB. Oh, there we go. And this guy should come right out. Should. Should's the key word, guys. Somebody's probably saying, Joe, just get some needle nose pliers. Nah, they're too far away. They're like 6 feet away from me. All right, and you can see I forgot this guy over here. Same thing. Got those ears that retain it. It's a little flat blade screwdriver. It's plastic, so don't pry out on it. Just carefully rock it, and it'll pull right off. So this, let's see. So this is your main controller board. This one right here, and this one here should be your motor and power board. So this one here is got your motor drivers, and it's also got your power. It's a tiny little fuse right here. So what else is going on in this board? It's got a nylon fastener. It's holding an inductor on. Don't pull that guy off. All right, so let's see what I've got holding her on. Okay. Let's see. Like I said, it's been a long time since I pulled one of these guys off, so bear with me, guys. Try not to break something, because this guy is going to go back together. All right. Should have known better. So I got another one of those plastic studs right here on the opposite side. Go. Come on. I might be able to just pull this guy up without it, eh? No, I don't want to flex the board. Here we go. Nice and easy. I'm trying not to pry too hard, and I'm trying not to bend the PCB. All right. So that there is the power board and the motor driver board. And it's also got some through communications. That's probably why it's got that large ribbon right there, so that the CPU board can talk to the CPU board of the module next to it. Anyway, that's it for my PCBs. Oh boy, look at this. All right, so This guy right here is what I really want to dig into. Let me see if I can disconnect some stuff and pull it out. Because this part right here has always amazed me since I was a junior biomed. How am I going to do that nicely? I'm sorry, guys. I haven't been paying attention to the comments over here. Just got ousted from a D&D game. Nice. Warmers are easy. I agree with Jay. They're not very complex, and once you get trained on one, you're gonna pretty much know most all of them. So it's a good way to get some training and experience. But your documentation, if you're doing incubators, be very thorough and follow the manual, because they're gonna test zones and modes and stuff. And there's such high liability when you're dealing with like NICU, neonatal and intensive care units. So if you're going to do incubators, transport incubators and stuff like that, do your documentation when you do your PMs. Trust me. I just spent 5 days in the hospital with my mom day and night. The sound of an IV pump alarms cause air in the line haunts my dreams. I think I'd enjoy tearing one apart right now. Enjoying this. Thanks, man. The air in line. Yes, we're about to get to that, because that goodness is coming up. There is a sensor for detecting some of that, and that's in here. That's what I'm pulling apart as we speak. Let's see. I can remember back when I was a junior biomed, I had so many of these to do. It was hundreds. It was easily hundreds, man. Right, so what is retaining me now? Is it? All right, might as well get into it. I was going to pull this little flap apart eventually anyway. So this right here, man, I forgot all about these little plastic doodads that are everywhere. They're such a pain in the butt. Hold on. If you're going to do this, you might as well do it with the right tools. This is just one of those times when needle nose makes the job so much easier. See? Nice and easy. Okay. There we go. Try not to break anything here. So this is that spring-loaded doodad cover. Notice it's got a spring foot right here that keeps it open when you open it up. And this guy, if you want to get to the sensors and stuff, you got to get behind this cover. All right, here you can see those peristaltic fingers that I was talking about, and your gates, which are spring-loaded gates. And these sensors have just this little tab right here on the side that hold them in. So all you gotta do is pull it back a little bit, and they pop out. You see that? How cool is that? And if I remember right, that's it. You can just pull them straight out. Yep. So that's the pressure sensors. Don't get them mixed up, and anytime you touch these whatsoever, do not press on the disc in the middle. That disc in the middle is extremely sensitive. Now, it used to be back in the day, because when I was in the desert, when I was in the war, what we had to do is if your pump goes bad and you need another pump, what you would do is you just press on these discs really lightly in a rotational pattern. And what it does is it kind of frees them up and it changes some of their values. And then you shut the pump down, you reboot it, and now your pump starts working and you can put it on a patient. I have had that. Yes, it is a Band-Aid fix, but you do some of the damnedest things when you're in a war. So it is what it is. So that's all it is. They pop in, they pop out. Very cool. If you are repairing these pumps, not only should you have some of these guys right here, you should have extra sensors. So once you change these out, you have to load the software, put the pump on a brain, and connect it to the software, and you got to calibrate this, and you just have to do it. All right, so I'm still trying to get this guy out. There we are. There's a lot of magic that's taking place inside this guy. All right, so when you load this guy in, this here, there's two sensors. You can see a sensor right here and a sensor right there. And what those sensors are looking for are these white ears. You see those ears? You ever wonder why they're there? They're looking for those so it can detect that the door is closed. Okay, so if you get those door open sensor errors, it used to be that this little guy right here wasn't adjusted right, so this guy might be off by a couple degrees and it's not sitting exactly where it needs to be for those sensors. Those guys are right here. Now, up here at the top, this is your ultrasonic sensor. Now, I'm going to do probably a whole video on each of the different types of sensors. This is an ultrasonic sensor, and what it detects is when your fluid set comes here in between it, it shoots a high frequency sound across this barrier. This should be an ultrasonic. If I remember correctly, it is. So it shoots a high frequency sound across this gap, and the water absorbs the sound and air does not. So it detects, based on a drop in probably amplitude, it detects that there is fluid going through. So whenever your fluid set runs out, your pressure sensors should detect it, and also your air and line sensor right here, which is your ultrasonic sensor, that should detect it. So there's quite a bit going on in this little guy, and it's, of course, like I said on some of the other stuff, they're a little over engineered, but it is what it is. There's another sensor up here, and I just do not remember what that guy is, not for the life of me. And I'm not gonna lie to you guys, I have no clue what that guy is. There's 4 wires coming out of it, and there's no labeling on the port. If you guys know what this this little sensor is right here, I'd really be curious to figure it out. It's got 2 windows, almost like it's an infrared transmitter and receiver. It's got 2 tiny little windows. No idea. Maybe that detects when the set is fully inserted. That might be it. It might detect the set. So let's see. Hold on, guys. Just saying, so I can read up on some of these comments. Matthew says, "Do you work on GE Panda warmers?" It's a good question. The displays do go out on those. You are absolutely right, because they never shut them off. And you would think that those things would go into a sleep mode or something, but they don't. It's designed obsolescence. They usually love to snap the side rails off them. I just spent 5 days in the hospital. Yep. Jay says, I've replaced a few LCDs. About a year ago, there's a recall on the main power board needing a fuse replacement. Interesting. I didn't know that. Probably because I haven't worked on these in a long time. Give the motor a couple turns and then pull the AIL sensor. You know something? We're going to get to the motor in just a moment. I've definitely had the motor froze up before. Jay, my name is Justin. My name is Justin, guys. My identity is not hidden whatsoever, except for my hospital, because people have tried to get me fired for whatever reason. Yeah, the service. Actually, you know the craziest thing about these guys? I don't think anybody has said what the sensors are on the inside. I can just guess based on the quantity of wires and their positioning. This guy over here, it's got 4 wires. It has to be infrared transmitter and receiver. Anyway, that's your little module that your consumable set will load into. Let's check out the motors, man. This is always really cool. So what he's talking about when he's talking about rotating the motor a little bit, that is this right here. Oh, actually, you know something? I am leaving out a pretty important piece of this. See this little hidden guy right here on the back? This is an optical interrupter, okay? And what that does is it tells it the position of the motor right here. So you can see it's on a gear reduction, and right here there's a crown with some slits. See the slits in the crown? And as you rotate the motor, it will occlude and interrupt that photo sensor, and it registers as a pulse. So based on whether or not it's open, you can see how it's got a long period of being closed, and then there's a short little blip, and it tells it its position basically. So it'll rotate the motor until like all the fingers are down and it's ready to be opened up and a new set reloaded. So that is the position sensor, is that little crown right there. Let's see. I have never seen orange paint on these before, guys. That must be a newer Care Fusion type of thing, because I don't believe they ever put that stuff on there before. Not orange, anyway. All right. I shall probably stab myself in the hand. All right. Clear some of the stuff out. I want to get these screws mixed up. So there's some cool stuff that's going on here on this module. I'll show you guys in just a moment. Wait. And what the heck, I'll pull the motor off too. All right. Wait. All right. So you can see the wires right here that were connecting those pressure sensors. All right. Take a look at this eccentric cam. And these channels right here ride on certain parts of this cam, and that's what actuates those gates that close off your fluid on your tube. So it just rides on the cam, and you can see how there's lobes on the cam. It's a really smart design. It really is. I dig it. So these guys here just pinch off the fluid flow, and it moves to this guy, and it pushes up on this guy, which rides on a cam. You see the lobes right there? So they just ride like that on the cam. And let's see, the other wastegate, or the other pinch valve is just spring loaded. It doesn't ride on the cam, I don't think. I think this one here doesn't ride on a cam. because I think this guy, hold on, see how this guy goes back together. It's been so long since I've taken this apart. Okay, so gear goes like this. This guy here rides in these channels. Should have been more careful when I pulled it apart, eh? Okay, there's two tiny little bearings on this guy. There it is. There it goes. Now you can see it. So you can see how it moves this guy up and down. And I think I see something else going on right here. I couldn't really figure out the purpose for this guy, but I think I just figured it out. Look at all these springs. Do you think I'm ever going to get this guy back together? Here's the key. If you ever don't know how to get something together, take another one apart and use that one as your example to put the other one back together. All right, caught it. Okay. I'm still baffled at what this guy does. Not really sure. You can see your tiny little stepper motor there. It's tiny. It is a stepper motor, unlike some of this other stuff that's using DC. That's because you can control the position of a stepper. So there should be 180 degrees or 180 steps, something like that. Yeah, just spins and spins. All right. Well, that is the Alaris infusion pump. Look at all those parts. Oh my gosh. There's probably 200 parts here. How crazy is that? Dan says the motor encoder is on top of that board also. Is it? You mean on this one right here? This optical interrupter? Do not remove the orange or torque the spec. Nah, remove the orange. Fuck them. All right. Let me clear this garbage off because I have the next victim. Boy, that's bringing me back some memories right here. Pull my tools off. Oh, let's see. Where can I put this stuff? See, that's what we need in shops to take stuff apart. You put all the parts in a bucket. Why not, right? You can put the lid on the bucket and you can stack them up so that, you know, as you take stuff apart, you can just keep them in one spot. Buckets are cheap. So after I do these teardowns, it's like a mental exercise. I come back like a day or two, sometimes 3 days later, and I put these things back together from memory just for practice. So if you're ever like, man, that dude's never going to put that stuff back together. Yeah, I do. Yes, I do. There's still some stuff yet to be put back together, and some of the stuff is going to be just victims because it's old. Some of these items are just going in the trash anyway. I mean, like I said, all these items, including this pump, were pulled out of a turn-in bin, you know, stuff that was basically getting disposed of. It's crazy that some people throw some of this stuff out, but it happens, man. It definitely happens. Oh, that's easily 200 parts. All right. Parts. You would think that they could have put this guy back together a wee bit simpler, you know, lighten up on their bill of materials for production costs, because we've got like, what, 5, 6 different types of fasteners, even though they're almost the exact same thread pitch. Why are some of them going to be Phillips and some of them going to be 2 millimeter? Doesn't make any sense to me. But hold on just a second. Had to solder the rookie diode back in the air and line board the other day. The rookie diode. Do you need a biomed degree to work on these pumps? Absolutely not. In fact, these pumps are usually how people get their foot in the door. It's very common for volunteers to go and you'll be stuck. I shouldn't say stuck. It seems like such a negative word. You'll be in a team and you will just be calibrating and repairing pumps all day, which can be really fun. I mean, you get really good at it. Trust me. Like, you can hear a pump running and you know exactly what's wrong with it. You get an error code and you'll know exactly what's wrong with it. And you'll be able to, whatever, you know, it took me to tear this apart, you'll get it apart in a fraction of the time. You'll get really good at this, man. All right, that's that victim. Ooh, guys. I don't know about you guys, but I have so many of these sitting around my shop. Do you guys in your biomed teams take care of vacuum regulators? So for those of you that don't know, this here is a gas port. It plugs into a wall. It's got a spring-loaded catch. You can see it right there. And what it does is you push it into the wall, it latches on, and then you attach your vacuum to the bottom, which is normally a water trap. All right, so your water trap or a fluid trap, it'll screw onto the bottom. And from there, you have a barb where you're going to plug a hose on. This one here, you can see it's set up differently. They forego the fluid trap on this one, and unless you got the type that adapts to it. But you can connect a hose straight up to this, to your machine, and just run it. So this is a it's a two-phase, shouldn't call it a phase. It's a 2-mode vacuum regulator. So you go one side. Oh, this camera. You go one side and it's just on, okay? The middle, it's off. And the other side, it's on intermittent. See that? OI, OI. So intermittent suction, which you're going to use that type of stuff if you are hooked up to a low volume chest tube suction unit, which I've been hooked up to several of those, unfortunately, throughout my life. So these guys right here have a wonderful function. They take central suction, central vacuum from your medical facility, and you can regulate it down to the appropriate level for your patient. Or you can go full nut and just suck the hell out of whatever you're vacuuming, right? So this is a press and turn regulator dial. So you press it and you turn it. But here's a special thing about these. I've actually seen this happen on lots of people. If you want to see how much vacuum that you are regulating, you have to occlude it, okay? So if this is running straight from open air and you're spinning this and spinning this and spinning this, and you're like, hey man, this thing's not doing very much, you have to occlude it, okay? In order to figure out what your suction pressure is. In other words, there's no suction at all, right? It's sucking air right from the room. So what I'll do is I'll get a couple gloves, knot them up or something, and you suck it right to the bottom, and then you just screw this guy and adjust your pressure. Nurses and stuff make this, they make this mistake all the time. They're like, hey, it doesn't work, it's not regulating. And then you occlude it either here or at the vacuum canister someplace, and all of a sudden, whoop, then your dial comes up and you can adjust your pressure. It's the craziest thing. Everybody makes that mistake. let's get right into it and let's see what's inside this guy, because this is more complex than the normal on or off suction because of that intermittent feature. And I hope that I can do it justice to explain what's going on with that intermittent feature, because it's pretty neat. There are no motors in this guy unless you consider an air motor. And so it uses the suction itself to actually create movement, almost in like a clock, you know. Kind of like your sprinkler in your yard uses the water pressure to control a water motor to spin, to move your sprinkler head back and forth. It uses a little bit of energy from that water flow to power a water motor to move your sprinkler head around. That's basically what this guy's doing, only with vacuum. Oh boy, there's so much stuff going on here. Okay, so first off, you can see right here, this is the plunger that is attached to your vacuum regulator knob, which is right here in the front. You can't see it because on the inside there is a geared tooth. So when this is being pushed out by the spring here, it latches into these teeth and you can't spin it, right? So that's why you got to push it in and rotate it. And all you're doing is you are depressing this right here inside the unit. And, you know, because of fluid dynamics, you are changing this valve down in here, which is affecting this guy. You can see we have a pinch valve right here. Let's see. Yeah, you can see it right there. What? Okay, there's your pinch valve. And on this side, I think it's just a plug. Anyway, let's see. How do I get this guy apart without completely destroying it? Anyway, here is the other part to that regulator assembly. So you can see the nylon threads. There's some grease on them, so that's another reason for wearing the gloves, obviously. So what you're doing with this guy is you're also moving it in and out of this channel right here, and you're changing the volume inside here. I don't think that's a really good explanation. There's a lot of stuff going on in this bad boy, man. And this is completely different than the other vacuum regulators I've tore apart. So I'm used to the older ones. I've never ever pulled apart one of these newer style. This guy here just falls right out. Your most prominent damages are either going to be your front dial, your window, and if your window breaks, they're going to booger this guy up. So this is your vacuum gauge. You used to be able to buy these as parts. I would assume that you can still buy parts. Dan says put $150 of parts into it, only to find out the main body's cracked. Remove said $150 parts. Put it in the boneyard. Yes, I have so done that. I've so done that. That, or I find out that they, you know, dropped it. This plastic back here, they crack it. That's probably what Dan's talking about. Is you know, you put all this work and effort into it, and then you find out that it's cracked back here. We've all done it, man. Are those required for vacuums? JJ asked. Required for vacuums. Anytime you connect a patient up to suction, because guys, suction is a crazy powerful force. Okay, it is, because we sit at what 14 inches of water. I think you guys might want to check me on that. It's like 14 inches of water is atmospheric pressure, and because of that, if you fall below that, all the room air here wants to invade that space. So vacuum is an extremely dangerous and extremely powerful force. Without this, you hook a patient up to the vacuum, and you can and probably will kill him, okay? Because vacuum keeps pulling. It'll just keep on pulling. Like when I was talking about the chest vacuum that I was hooked up to, Without this guy right here, it would have deflated my chest cavity and killed me. Probably sucked the fluids right out of your body, you know, because you have a positive pressure, which is your blood. You have atmospheric pressure, which is lower than your blood pressure, and then you have a vacuum going inside your body cavity. This guy will mess you up if it's full on. So if like the intermittent isn't working, if you occlude it and your dial regulator isn't working, do not put that guy in service. Do not. You can kill somebody, okay? So like I said, vacuum is an incredibly powerful source of energy. I really would love to pull this assembly apart here, but I think it's going to make a mess. So you can see a couple of the filters. There's some calibration right here. I've never done that. Here's also on the brass. The brass is probably the one that you're going to adjust. I've never done it. I wish I had a wall suction here because I would mess with it right now just to see what it does. I mean, why not? Every hospital has these just laying around. Oh, Dan. Yes, sir. The Neptunes. Back in the day, Neptunes used to be pretty much plugged in everywhere, straight to wall suction. And you plug a Neptune into wall suction and you hook that up to a patient. And it did kill somebody. It did. Neptunes are a large canister that used to hook up the wall suction. And this canister would basically collect all the body fluids and stuff. And then you wheel it someplace. I'll do a video on it, guys, because the Neptunes are actually a very cool and very disgusting job, okay? And you got to know what you're doing when you handle them because they are contaminated at all times. They're disgusting, but they serve a very important purpose. So Neptune's a canister that they collect patient goo, and then you wheel it to like a decon closet where it connects to a dock, and it sucks it out and it flushes it into your water supply. And then it sanitizes the canister. The old versions, like the ones that I got started on, it's literally just a canister. The new ones actually have an integrated vacuum pump, and they got multiple chambers, and that's good or bad. I don't know how you feel about it, but I've had a lot of issues with Neptunes and stuff, but at this hospital, I haven't had those problems. I'll do a video on it because it's a very cool device, and I think it is one of those things that has kind of changed the way that we do business for the better. Anyway, I want to show you guys something right here. Okay, so you can see this guy right here. You see these channels? All you are doing is you're rotating these channels back here. You see those ports? And you can see the grooves right there. So when you rotate this from one stage to the next, what you're doing is you are now putting an airflow, which is vacuum, through your air motor that I was talking about. And your air motor, at least on the old ones, used to spin, and it's timed so that it spins with the suction, and then it releases, right? And then it spins, and then it releases. And that is what turns your vacuum on and off. Now, this guy is built a wee bit better than the ones that I remember, okay? And I imagine there's 4 or 5 different gaskets on there. These are all gaskets. This guy is going to be a complete pain in the butt to pull apart. So that's what I'm going to do. That's what I'm going to do. Let's pull this guy apart because I've never opened one of this ever before. Did I do that 2mm? Oh boy, I'm definitely having one of those afternoons. You guys ever have one of those days where like you get to work and you start working on something, you flat surface something? Flat surfacing is when you place something down, you don't remember where the hell you put it down, but somebody asked a favor of you, or you had to answer the telephone or something, put it down, you don't remember where the hell you put it, and that's flat surfacing. And I suffer from that really bad, okay? People ask me questions throughout the day, guys, and as people are asking me questions or say, you know, figuring out what's going on or whatever, I get distracted. So I kind of wish my office was a little isolated from everybody else. Not necessarily because I'm an introvert, but because I can focus a little bit better, man. I flat surface stuff all the time. Wow, that's a lot of fasteners. With all those gaskets, all those different plates, and all these gaskets, you know that there's some complex stuff going on in here. Let me tilt this back down so y'all can see what I'm doing. Okay. So you don't have to get hairy-carry on them when you torque them down, that's for sure. Because, I mean, they're slightly tight, but not crazy. It's a well-made device if you think about it. I mean, there's minimal moving parts, and minimal moving parts that we do have are just channels for routing suction. That's definitely a good one. All right. You can feel these plates starting to relax. We're going to figure out if these are calibrations. I'm assuming that these are this one, and this one. We're going to figure that out real quick when I get this guy apart, because I've never really known how to adjust these. Oh, you know what it is? Okay, so these are probably going to control your vacuum motor that I was talking about. So that's your timing. And there is there's a specific stat for the timing of this guy, and you can adjust that. Oh man, I see some good stuff in here. All right, let me clear this out. All right, let's start with the front face. That'll make it easier. Come on, come on, come on. Oh no. Okay. Well, you can see that there's a diaphragm. Hold on, hold on, hold on. You guys don't want to see me. You guys want to see what's going on. Okay, so there's a spring right here. Let's see. I know I'm going to mess this guy up. All right, so it looks like we have, so this one here is a needle valve, and this one here probably controls the amount of air that goes into the air motor. So the brass looks like it controls the air that goes in and out. It comes down here. Let's see, I don't remember where this guy went. I guess it goes in that hole right there. So it's got a diaphragm. I wasn't expecting that. It's actually very complex. Wow, these are really stuck together. Hold on. Come on. I wonder if it's this guy right here. Yep, it is. Okay. So that is the needle valve that I was talking about. So needle valves are used for adjusting or calibrating the amount of flow. All right, you can see right here your filters for your input, I would assume, and output. To keep your valve body and everything nice and clean. Wow, holy cow, look how complex this guy is. All right, so I got a taper spring. It looked like it was mating up with this guy right here, which goes through a couple different plates to this side, and it opens and closes a valve. Wow. So this guy doesn't have an air motor. Not that I can see. Wow. Look at all these channels for vacuum. Whoever designed this is an absolute genius. Absolutely. I couldn't even fathom to tell you what the routing is either. mean, not that it matters. You would just change out this component if it's ever bad. But wow, there's a lot of stuff going on here. So you guys probably recognize these type of valve seats right here. That's for your diaphragms, which are right here. And you see these all the time on sterilizers and all sorts of different types of medical equipment. You also see them especially on anesthesia machines. I see these. You see them on ventilators, stuff like that. So it uses fluid pressure that comes in from the side, and opening, closing. The valve opens and closes from this valve seat. Come on. Wow, this guy is really on her. I'm never going to get this guy back together, guys. Never, ever. Although, maybe I'll try. Okay, I think these guys right here are holding it all. There we go. Okay. Wow. All right, so here's an interesting development. I was wondering why the backside of these look like this. Those look like they're snap retainers. See how it's kind of pulling through like that? So what it is doing is when they assemble these, they snap these together as a unit. So you can see right there, see the discs? They'll hold them on. So this side here goes through the two plates, and a retainer ring fits on this side, snap, snap, and now it's an assembly. So those guys, unless you're going to booger it all up, you are not going to pull that guy apart. This is crazy, guys. All right, all right. I have no idea what's going on with these. That's the truth. So the old ones had like a little kind of like piston assembly that was moving inside it. And this guy here looks like it's all passive. It's, I don't know, unless they maybe timed it out for how long, you know, this valve opens, which then goes over here and opens that valve. I have no clue. But fewer moving parts is a plus for reliability. Well, nothing much there. This is just like a manifold. All right. Well, that was simpler than I thought it was going to be, guys. Dan says the Neptunes are under contract for a reason. You are damn straight there. I don't care how much that contract costs. There's one contract you pay for, and that's Neptunes. Neptunes, the new Neptunes do also have smoke filters in them. It's a carbon filter that it sits in the side, and the vacuum will, you know, suck your gases from when you're doing electrocautery surgery. And instead of all those fumes just filling up the room and choking everybody out, the canister collects all that debris and the smoke. So, yeah, Dan says Neptune 3s have built-in smoke evacuation. You are absolutely right, man. JJ says, I've never worked on vacuum before. They're just used for sucking up surgery, gunk, and smoke. These vacuums are used for all sorts of stuff, right? They're used for all sorts of stuff. So not just sucking up patient goo. These things perform a variety of functions, and there's different attachments you can connect to them and stuff. But the important thing is you can see all the parts to pull this apart. Usually, you will have a local company. If you live in any major city, you're going to have a local company that will refit these. Or maybe you want to start a company refitting them. You know, you get all the parts, you just rebuild them. You get your silicone grease. But man, there's actually not too much to them compared to the old ones. So you're going to go through some dials because these guys get smashed. You're going to go through some windows. You're going to go through some knobs, maybe some outer cases. They always seem to crack this guy right here because when it's plugged on the wall, they smash into it and it always fractures it. What do you check on a vacuum PM? All right, it's a good question actually. So if you're doing a PM on these, which a lot of hospitals quit doing PMs on these, it's considered a low risk item, so there's no PM on them. But if you are at a facility that does have these on your maintenance schedule, then well, in fact, you can see right here, no PM required. At my facility, at yours, it could be different. But what you are going to do to do a PM on these, you're going to occlude it. All right, and then you're going to check the range on the knob to make sure that your gauge goes up and goes down correctly. And then for this intermittent suction, you're going to flick it over on intermittent, and you're going to occlude it. And then you are going to watch, and it should go psss, and then all right. So you're going to check and make sure that the intermittent function works. If you want to really get into it, there is a specific amount of time, like within plus or minus a couple seconds for these. You can look it up actually on the website. If I remember right, there's a very specific amount of seconds, and if it's outside of that range, because remember I said the old ones had like an air motor in them, and it would get gunked up. There's a bunch of stuff that would happen to them. O-rings get old, stuff. So anyway, they would start to lose their timing, or they'd lose their intermittent function completely. So because of that, they would have to get rebuilt periodically. That's the Ohio Medical Intermittent Suction Unit. I guess the most important thing for you guys to come out of is if you need to adjust something. Your little brass right there, it's brass for a reason, right? This right here apparently adjusts the vacuum that goes in, and it controls your timing of your circuit. I don't know what the other two do. That's these two right here. Yeah, there's a micro adjustment on these two as well. Maybe on time and off time. Not really sure. So you control your vacuum pressure that goes into it, and then on time and off time, something like that. Run till it flames. So you never do a PM on a Neptune either. Just leave it to contract. Oh my gosh, you guys. Neptunes are absolutely disgusting. You do not want to do a PM on a Neptune, all right? Leave that to the guys that come in with the spacesuits, all right? If you think I'm exaggerating, when those guys come in to do a PM, if they're really properly trained on their PPE, they will come in and they wear a spacesuit, and you know, it's kind of like one of those suits that they use for when they're doing orthopedics for total joints. So it's completely disgusting. You don't want to get into it. Just let the pros do it, man. If it costs you $10,000 a year to do a PM, you pay $10,000 a year. It's not that expensive, but what I'm saying is it doesn't matter how expensive they are. You do it. They're disgusting. All right, let's see. Where can I put these parts? Another bucket. You can never have enough buckets around your shop. I'm probably going to try and put this guy back together. What a cool 3D puzzle, huh? I'm going to try it. So you can see the indents on the gaskets, so you can guesstimate what side goes to where. I'm going to probably do it. Don't want to lose the little O-rings. Or the really fine springs like that taper spring. all these O-rings got a grease on them, so they want to stick to my gloves. Right. All right, all right. Next victim. Look what I pulled out of the trash, guys. What a treasure this is. Now, if I remember right, these guys are still like $700 or $800. So this is obviously a security camera, but the cool thing about these guys is there's probably servo motors in there that control the positioning. So you have, well, there's going to be multiple. So you're going to have X, Y, and probably focus, so Z. I'm going to figure it out. So there's security bits around the perimeter. Let's see if I can get those off. I don't know if I've got the correct bits here at my desk. Oh, yes. Yes, I do. Jeez. 3 strikes and I'm out, huh? All right. So these cameras, they use them all the time in EEG, which is electroencephalograph monitoring. That's EEG is a section of the hospital that they put sensors around your skull and they monitor brain waves. And they do that especially for epileptics. But you can also have EEG and cameras for like sleep studies. If people have weird habits in the middle of the night that they're unaware of, like maybe sleepwalking or RLS, restless leg syndrome. Look at this. These things are just so cool. So you can see what I'm talking about. The X, the Y, and the focus motor would be your Z. You can tell when you rotate a motor that when it makes that zzz, zzz, zzz sound, that is a stepper servo motor. I guess I don't care if this ever gets used again. If you ever have steppers on a device, it's never a wise thing to sit there and move it back and forth because stepper motors generate DC electricity, which can feed back into the control boards. If they don't have like shunting diodes, it'll feed back into them and it can blow up the boards because they create a lot of DC, quite a bit actually. So that's why it's never a good thing to do this, but who cares, right? I don't know if this guy's ever going to see service again. Probably not. It's going to be my victim. But this is another one of those poor souls that was not being loved. I just found it in the trash. Right. Yes. Oh, that's so clean. I dig that. Let me get the fasteners out. All right. The reason I was so excited, guys, is because they made this serviceable. Instead of using ribbon cables or any of that kind of garbage, take a look at what they did. They have a press fit connector here and here. You see it right up there? So when they made up, it just naturally sits in. It's nice and easy to change out. There's just 3 fasteners around the perimeter that secure it in. Wow. So you can see the motors right here. So these are just stepper motors. They're not servos unless there's something else going on. I think they're just steppers. Yep, just 4 wires. So what else do we got going on here? Obviously, this is the main rotator motor, and it goes to, oh, there you go. That is not the main motor. This guy is your camera? I think that's the camera, guys. What a cool design. So see right there, you see how the motor just runs around almost like a sun and planetary gear, only it's running on a belt. And in the very middle, your sun is a stationary plastic gear that is molded into this. So your motor actually spins on a belt that is technically being held stationary. That is so cool. So your motor rotates around your sun, which is this large gear in the middle. See, I don't know how to take that apart. You know what they say, just start pulling screws out, right? I didn't know Biomed's work on security cameras, Neat says. Is there anything else that Biomed's work on that isn't Biomed? Well, since security cameras are going to be interfaced into the EEG monitoring system, yes, Biomed can, will, and do work on your monitoring system. They also use these orbital cameras on your portable EEG monitors, which is basically like a computer on wheels, and it's got this tower with this camera at the very top. So when the patient starts having an episode or something, the staff can actually monitor it remotely from this guy. And these guys are also located on some of the remote translators. It's a computer on wheels, and this guy is up on a boom, like so, and it's looking at whoever the translator is speaking to, right? So if the family is there, the translator can rotate it between people when they're talking to them. So these things are on all sorts of equipment, and you know, like I said, normally you just pull it out and you change this out as an assembly. So this guy here is going to be screwed into the facility, or you know, into the drop ceiling, or this guy here is going to be mounted to the boom that's, you know, on the medical device. When you want to change out the camera, all you got to do is pull out those 3 fasteners. Your camera pops out, you pop the new one in, you put the globe back on, and you keep trucking. Pretty simple. Let's pull out this last one. Let's see if I can separate this. That is so cool that it runs on a belt. Hold on. I know before I unscrewed that board, I should have pulled these out. My bad. There we go. It's not easy doing this with gloves on. There we go. All right. This matted up mess right here, I think, is my camera. Come on. There we are. Wow. Okay. So remember on the last device I took apart, well, not the last one, on the infusion pump, there was a photo interrupter. Well, here is a larger version of that, and you can see right here the crown that looks like it's equally spaced around the perimeter of the camera. So it counts the pulses as you're going around. So if you say, hey, you know, from your camera control console, if you say, hey, I want it to spin 90 degrees, it knows how many pulses until it gets to 90 degrees, you know. Okay, so I do believe that is my camera, and you can see it's held in by 3 fasteners. know I should take these gloves off. It'll make this way easier. All right. I don't want to yank on this little guy right here, so I'm pulling out the 3 center fasteners. I wanted to pull out the whole block assembly, but apparently that's not a good idea. Oh, no way. Okay, guys. I should have known better. All right, guys. They got me. So this guy right here is not the camera. I was thinking about it, and I was like, man, that means that you are flipping the camera around when it rotates. So this guy is a commutator. And a commutator is usually like a disc of brass traces, and there's little fingers that run on those brass traces, you know. So as it goes around, it allows you to rotate it more and more and more. So there's no wires that connect between this half and this half, right? Because you have a piece that moves and a piece that's stationary. So this side is the stator, and this side here is your commutated side. So it's a commutator. There's wires that are holding it on, so I can't pull it out. That sucks. And I don't know how to pull that apart. Yeah, it's not coming off. Well, shoot, guys, I don't know if I can pull very much else apart on this guy, because if I do, it's going to be a permanent situation. That belt is going to be a pain in the butt to line back up. I can tell already. You can see the belt that I'm talking about right there. Shame. So that's a commutator. You're going to see commutators on things like surgical booms. You're going to find them inside overhead lights that you can manipulate around. You see commutators all the time, obviously in cameras. You're going to find these all over the place. And if you're in like an operating room, your commutator is a common point of failure. So if you have surgical lights that are intermittently working as you move them around the room, you can often replace your commutator or adjust the commutator fingers that run on the center post. But we'll do that in some other video in the future. But yeah, a security camera, although not always used for security. They often use them for patient monitoring. Wow, guys, I have certainly made a mess. Inside the shell here, there is an antenna. What? So this guy right here looks like it's an antenna. Let's pull it apart. I don't know if this is a Bluetooth capable camera or if you use that to control it, maybe with like a wireless controller. That's what it looks like. Oh, okay. What else is that? Okay, so there's a cooler. And wow, that guy's really stuck on there, isn't he? It definitely looks like an antenna. So there are traces that go back and forth on a PCB, and there's 2 wires that connect to it. Oh, is this a transmitter? I don't know. But you can see that there's a fan on it cooling it down, whatever this guy is. I have to do some research on there. I do see one tiny fuse on the PCB over here. It's this little tiny white guy. So if you have a power spike or something like that in your building and you lose a couple cameras, you could probably solder a new fuse on that board and be back up. So that looks like it's just an I/O board, but it's also got some voltage regulation on it, which you can see by the transformer and the miniature MOSFETs that are around it. Yeah. I think these guys here are Omron relays. I wonder if those, yep, those would probably for controlling the motor. So I can tell by the number of traces on those relays that that's probably forward polarity, reverse polarity, or wait a minute. No. They're steppers. And this is your driver board. Okay. So it monitors the position, and this here has got your drivers, and there's also a fuse on this board. Okay. Well, it doesn't matter. You're going to change the whole camera head out as a unit, as a part. And this guy here is going to stay in the ceiling. And if you still can't get your camera to talk after that, there's a good chance that maybe you pop that fuse on this board, since this is your input power. Here's your video out. Sure, 24 volts in. And what is this guy? Okay. So you got serial communications to control it. And it looks like these say they're all alarms. So here's your serial. It's TRX plus, TRX minus, and then signal ground, 3 wires. And that is for your controller console. Anyway, Raven, what's up, man? How you been? I know I didn't advertise that I was going to be doing some teardowns and all that buzz, but you know, why not? I've been abusing this whole time. I've been sitting here, and I've got a drink off over here to the side, and I'm just chilling, tearing some stuff up here. Why not? Love the Weehaw sets. You know something? It was actually I am obviously a fan of Weehaw tools, and it's because of X-Ray that I learned about Weehaw, because they actually give away some Weehaw tools with certain devices when you buy the device and it gets installed. And ever since then, man, I've got all sorts of Weehaw tools, man, just all sorts. Like this mini driver kit right here, precision driver bit set. This is an excellent kit. I really like this guy. But you can see I keep it here at home instead of being at work. I really wish I had this benchtop precision driver set at work, but you know how things are, man. I keep as many tools at home as possible right now. Man, I do have some cool stuff as soon as it comes in to show you guys. I bought into some of the Milwaukee Packout drawers. If you guys didn't know, Milwaukee Packout has drawers that are new for 2021. They just opened up for ordering like a week or two ago, something like that. And now I currently use the Milwaukee Packout system, and you have your large rolly chest, and then you have your smaller ones that attach to the top of it. And it's good. It's a good system. The problem is if you have to access, like I keep my multimeter in the very bottom one. I keep my impact driver and my drill and some of the other larger stuff in the bottom one. And I'm telling you right now, it's a pain in the ass to pull those apart to get to the bottom one, and then to you know, put it all back together again. So Milwaukee Packout now has the drawers. So there's a 3-drawer, and they're smaller, and then there's a 2-drawer, larger drawers. And Then there's also a Milwaukee Pack-Out 2-wheel dolly cart. So I don't know about you guys, but I have a large facility, and for me to move around boxes, medical equipment, it would be nice to have a dolly. So very soon, I've got the dolly in my house, but very soon when the drawers come in, I'll be doing a video on that, because that is going to be the future for how I'm going to be running around fixing stuff. Because currently, taking everything off to access a multimeter in the base cabinet is such a pain, because I use my multimeter a lot. I don't know about you guys, but I use my multimeter quite a bit. And I always keep it in the bottom cabinet, because it's safe from theft. You know, it's too easy for me to park my tools, even in the bathroom or something. And, you know, somebody comes in, oh, shoot, oh, fluke multimeter, and nab it, you know, and walk back out of the bathroom or something. Who knows? So I keep that stuff, you know, reasonably well locked down. But so that's going to be an upcoming video as soon as they come in, hopefully in the next week or two. I've got so much stuff. Everybody has been giving me so many suggestions, and I need to have a pad of paper here so that I can write down, like when people talk about what would make a cool video, I could write it down and then, you know, use it as like a checklist. I have had, believe it or not, I have had 1 or 2 people that have gotten upset because I didn't make the video that they wanted. Man, I can tell you what, nothing makes me want to hate doing these videos more than somebody telling me what to do. I love helping people, don't get me wrong, but some people really just piss me off. And they try and they get upset because I didn't make the video that they want. Guys, I work in a facility, and a facility that doesn't respond well to videos being recorded within the premises. Okay, so any videos I do make within the premises, they're discreet and they're at my leisure, because I don't know about you guys, but I like my job, sort of, and I like getting paid to do my job. And for that to abruptly stop, I think would ruin my week. So guys, if I don't make a video on something, it's because I'm not exposed to that equipment at the time being. Kind of like earlier this week, last week, something like that, I made a video for perfusion repairs. That was because somebody came to me and said, Justin, what is going on with this? Can you please help us out? So I took a walk around and I said, oh my gosh, I've been waiting for this to happen so I can record this video, because I did have a patient that crashed because of that particular repair on a perfusion pump. So since that happened, and then I went to a training room, which is a classroom for perfusionists. That one also had a broken latch. So I recorded, you know, my video in 2 different locations. So it is what it is, man. But when I run into stuff, I try and do it. This month is defib month, and guys, I don't know about you, but like I said, people are constantly bothering me throughout the day. I love helping, so I shouldn't say bothering like it's a burden, but I have to focus for some of the stuff that I got to do, man. I got projects that are being run. I'm running team. I'm trying to also inventory my facility and stuff. It's, guys, there's a lot of stuff going on. And I just wish I had a private office where sometimes I can close the door and like close out my work orders for the day or something, because people just come right up to my desk, and vendors walking in, and just random people coming in all the time. So if I don't make a video that I say I'm going to make, just give me some time. It's all about opportunity. And sometimes I'm waiting for that perfect video, you know. If I just get some half-ass attempt, I'm not going to do it. I'm not going to do it. It has to be right. And a lot of these problems that I'm making videos on, I see this stuff all the time, man. You guys see this stuff all the time. Hopefully not. But so, you know, it's all about getting that right opportunity, man. I am a team lead, Mr. Chris. So I was a team lead in charge of operating rooms, and now I am a team lead in charge of a lot of other stuff. It's very vague, and my job is incredibly large at this facility. I wish I could tell you guys where I currently work so that I could show you like a diagram of my facility and show you like all the areas that I'm responsible for, because it is crazy. It's crazy. I'm in like a 14 or 1500, maybe 1600 bed facility, and it's just crazy, guys. Like I'm in charge of 2 large towers. One of them's like 20 some floors. The other one's got 6 to 10 floors, and there's departments in these buildings that I don't even know about until like they call with a problem or my monthly PMs are due. And I'm also in charge of all the laboratories in my entire facility. Every laboratory and every OR, there's a little laboratory here, here, here. And then there's a massive lab where they do, you know, all the processing for this 14 to 1600 bed facility. It's massive, man. My hospital has, shit, they're still opening ORs. Honestly, they're still opening them. And this summer, they're opening more ORs. So currently, it's 72 to 80, depending on which ones are open. So it's 72 to 80. And, you know, depending on what hallways closed off this week for construction or whatnot, that's why it's such a vague number. But yeah, and for like months and months, it was just me and a Biomed 2 running 70 some operating rooms. And there's some technicians that were talking smack because, we used to do all those operating rooms with only 2 people. Why can't you do it? And it's like, are you serious? I work at a major trauma center too. I guess I should bring that up. So we do lots of transplants, robotic surgery, everything that you can imagine. We're a training hospital. We're a big time player in Houston. All right, we're one of the biggest games in the medical market. All right, and this is their flagship facility. And for months and months, there's only 2 people. And then I complained and I said, guys, we cannot do this correctly. Now it'd be different if all my ORs are in this building, right? So I've got like 31, 32 ORs in this building between this floor and this floor. And then I go into the basement of this other building on one side of campus. And I go to this part of campus across the way. There's like another 10 cardiovascular rooms plus 6. There's 6 cath labs. You know, so I mean, there's labor and deliveries in another building, you know, 7th floor or whatever. It's just crazy, you know, and you know, 2 people were running around doing all that, right? Plus our PMs. So guys, oh my gosh. CardioEquip came to fix a heater cooler and mentioned Hospital City. Hospital City. Chris, where are you watching from, man? Where are you at? I'm curious, because CardioEquip is prominently around Texas. You're in Michigan. Oh shit. Born and raised in Michigan, man. Okay. Michigan. CardioEquip is in Michigan. All right. Well, I'm pretty sure you haven't seen my videos on CardioEquips because that is the reason I'm no longer a team leader for the operating rooms. And someday when I'm no longer working at this facility, I can tell you guys that whole story, because there's some crazy stuff that happens in this world, man. Crazy stuff. Mount Pleasant. Oh man, I used to drive through Mount Pleasant to go gambling. Good stuff. Good stuff. That was Mount Pleasant. You had to drive through Mount Pleasant to get up to northern Michigan. I used to fix photocopiers, fax machines, and industrial printers in Michigan, and I used to drive all around the state, from Chicago up to the UP, all over the place, every single day. And in one year, I recorded like 111,000 miles on my logbook. That was a lot of road time, man, fixing stuff. So I used to drive through Mount Pleasant all the time. Good stuff. Well, guys, I'll tell you what. I have made one hell of a mess here, so I'm gonna have to figure out how to clean some of this up. Matthew says, what qualifies somebody to be a team lead? Experience. No degree is going to help you there, okay? Experience is going to help you become a team lead, because you have to know your stuff, and you have to be able to multitask, extremely well. You have to manage people, which can be a burden. it's a big burden, man. But being a team lead and developing a beautiful team where like people actually care for each other, leave no man behind type of stuff. I've been there, and I've been there a couple times. This operating room that I was at here, this is one of the best operating rooms, by the way, I have ever worked in, ever. Now, every place has their falls and whatnot, but I have worked in quite a few operating rooms over 15, 16 years, doing it 17 years. It's been a long time. I've been a biomed for 18 years, so it's been 17 years in and out of operating rooms. But I've worked in a lot of ORs, man, and this place has their A game on, right? Every place has their problems, but this place has got a lot of stuff going right. So I really liked working there, all right? And I'm no longer the team lead there. And instead, I'm a team lead downstairs where I am currently, this whole entire week, I am straightening out years worth of debris and collected old parts. Old parts are my number one pet peeve. Number one pet peeve. You guys, if you ever remove a part from a piece of equipment that's even questionable whether or not it's good or bad, throw that damn thing out. Throw it out. Why the hell are y'all saving parts, man? There is nothing more annoying, and the liability. I mean, some of you guys that are experienced out there, if you have grabbed a part off the shelf or off a flat surface someplace because they say, oh my gosh, I have an emergency over here, you grab the parts that you think are going to solve your problem. You go there only to figure out that power supply or that valve body or something is used, and it's still got the problem. So then you got all these people standing around watching you because you think you're coming in with the parts to fix the problem, and it's still broke, or maybe it's worse than it was before. I've been there, man, and there's nothing more annoying than that. Oh, I tell you what, if it was up to me, people that keep old parts laying around, I'd get them fired just because of the liability alone. Throw that crap out. Throw it out, man. How is your defib PM? Almost done, man? No way. No way. I still have over 200 defibs for February. 40, some of them are assigned to me personally, and it'd be different if I came in nights or weekends and that's all I did was defibs. I'd crack that out. No problem. But throughout the day, I mean, on average, I get between 6 and 10 repair work orders throughout the day. And my campus is big. It's all over the place. So how the hell am I going to get defib PMs done when I'm doing easily 6 to 10 repairs per day? And I waste no time, guys. No time. I'll tell you right now, when I come on site and I'm doing some repairs, I can get some stuff done. But there is a reason. There's a reasonable amount of time, and I'm not going to pencil whip the defib PMs. If we're shorthanded as a department and they don't want to hire new people, well, guess what? You're going to suffer for that, because repair work orders, when they come in and like they say, hey, we got a patient on the table, or hey, I got a lab analyzer down or whatever, that's your priority. Got an x-ray room down? Yeah, let's see you put off your x-ray room for defib PMs. Ain't going to happen. One phone call to the VP of the president and your ass is grass, maybe fired, who knows. So yeah, it's pretty crazy, man. I know some of you guys are probably shorthanded too. It's just the place that we work, man. It's the current environment. Let's see. I want to answer Sneed's question, man. Sneed says, do you see a lot of biomeds retiring? I heard a lot of biomeds are aging out of the workforce. Oh my gosh, Sneed, man, you are going to get me on a topic. I could spend a whole entire hour on that alone, okay? Easily an hour, because some of these guys got to retire, man. Some of these guys got to retire, and other guys that are some of the old timers that have been there for a long time, you need those people. They know people. They can make one phone call and they can get entire departments to stop what they're doing and whatnot. You need those people. But then again, you got the other guys that are just, you guys are going to have to forgive me. You can call them turds, okay? They're floaters. So these guys, they've been there, they got the tenure. They often work themselves into a very comfortable position doing, cherry picking what equipment they want to work on or working for the easiest departments. They don't have to deal with the stress and the high tempo of workload. So why would they retire? They've worked for years to get to this comfortability, and Biomed is plagued with people that have been they're floaters. They're just, every single hospital has people that are just sitting there talking on the phone, or they got their hiding spots throughout the facility where you'll walk by, pushing a cart or something, you'll be like, what the hell? You see a couple guys sitting over in the corner talking or something. Man, it is everywhere. Or you got the guys that'll walk around the hospital and flirt with all the nurses. I've seen it. Matter of fact, I see it all the time. It's the hospital that I currently work at, you got the facilities guys, and we have a lot of facilities guys, but you walk around and you see like they're working 2 and 3 people on what should be a simple work order, but they got 2 or 3 guys working on it, right? And these guys look like they're like 70 some years old, and it's like, oh my gosh, guys, I admire people that are motivated workers and stuff, but admittedly, some of these guys are working at 1/4 of the pace, 1/4 of the pace. But some of them are really hard workers. So that's every place has this problem. Every place. Anyway, guys, I am sorry to cut you all off. It is 2 hours and almost 30 minutes. I can't believe I've been here for 2 hours and 30 minutes talking to y'all guys. I love this. I made quite the mess here, but I have got to go inside and put Creature 1 and Creature 2 to bed. So it's getting a little bit late. Thank you guys so much for coming here and tuning in. I love this. I love doing this stuff with y'all. I'm going to experiment with some stuff very cool. I'm going to do some electronics experiments here just to get you guys into the theory. I know some of you guys probably understand your polyphase electrical and your brushless motors and stuff, but to experiment with it live with such quality components, I can't miss this opportunity, man. And I'm going to do videos in the very near future on types of sensors so that you guys know how to operate them, how to identify them, and what they do. There's sensors all the time. So they're going to be a series of short videos on the different types of sensors that we see: Hall effect, opto isolator, just a variety of them, pressure sensors, pressure transducers, just a bunch of stuff. And they're just going to be maybe 3 or 4 minute videos on what it is, how it works, and how to test it. And those are in the pipeline. I've already started writing the script on some of those, and now I just got to find the correct components to record and to demonstrate. So in the works, guys. But I hope you all have a wonderful night. Thanks again for tuning in, and tomorrow's Friday, guys. One more day. One more day, guys. But I'm also working Saturday, so it doesn't really matter. But one more day, right? Subconsciously. Thanks for watching, guys.